Hello, Professor Deb here. This video lecture is on technical mathematics, and we're going to be discussing the chapter Nonlinear Inequalities. There are several video lectures in this series, and they're posted on the website. Let's start taking a look at this one. The method that I'm going to use today is different from what some professors use, but I think it's a method that is understandable by the students and can quickly come to the correct answer. So let's start with this equation, and if we set these equal to 0, so we have x minus 4 equals 0, then x equals 4. And we'll do the same thing on this side. Now we'll worry about this greater than in just a minute. Okay, now these are what I refer to as the pinpoints. I'm going to put 0 in here, and I'm going to put 4 in here, and I'm going to put negative 2 in here. Now let me give you one little thing that you're not going to remember that we'll work on as we go through the problems. The greater than symbol is going to be correct with the plus columns, and the less than symbol is going to be true with the negative columns. Now I'll remind you of that, and we'll see that how that comes into play. Alright, our products are x plus 2 and x minus 4. Okay, we put these over to the side. Now you know what? I'm going to want 4 and negative 2 down here. So give me just a minute to clean this up a little bit. There we go. Oh, my straight lines are not quite straight today, are they? Okay. Now, x plus 2. X plus 2 is greater than or equal to 0. Okay. If we pick any number along this line, that would be 5, 6, 7, 8, 9. Let's say 5. Okay, let's pick 5. 5 plus 2, would that be a positive number or a negative number? Be 7, positive 7, so it would be a positive number. If I take that number again, 5 minus 4, that would also be a positive number. Okay, now let's go inside here. We're inside the 4 and negative 2, and I'm going to take that down so that it doesn't confuse you. Okay, now we have to work with the numbers between negative 2 and 4. And my favorite number is always going to be 0 because it's so easy to put in there. So we'll do the same thing. 0 plus 2, is that positive or negative? It's positive. And 0 minus 4, is that positive or negative? That's negative, right? 0 minus 4 is a negative 4. Okay, how about negative 2? Let's pick a number over here, negative 3. Negative 3 plus 2, is that positive or negative? Negative. Negative 3 minus 4, Is that positive or negative? Negative. Then we're going to find out what the product is of these two binomials, because that's what we're doing here, is multiplying these two binomials. Okay, a positive times a positive is a positive. Doesn't matter at all what the number is. You're just reading the signs now. A positive times a negative is a negative. A negative times a negative is a positive. Okay, now I go back to this nomenclature that I said. We have greater than or equal to. On a greater than, I want the positive columns. Okay, so I want this column and I want this column. Now, it's greater than or equal to. It's greater than or equal to, so I have a solid dot here, and it's this column, isn't it? The positive column. And again, it's a solid dot, and it's this column. So let's write this. X is less than or equal to -2, and X is greater than or equal to 4. That is your answer for this problem. Now you see, by doing this little product thing here, we were able to establish right away which part of the graph was the correct part. Right. Now you can do this. Some people are able to do this very easily, determine what you have to put in for x in order to get greater than 0. Where it gets tricky is when you have 2 or 3 binomials divided by a binomial, and all we're going to do is put them up the right side and put our pluses and negatives. So right now on the simple ones, it's pretty easy to do. Okay, here's another one. Well, first we'll have to solve this problem. And how do we do that? We factor it, right? So what is that factor? X plus 2 and x minus 1. So if we take x plus 2 equal to 0, we get x equals -2. And if we take x minus 1 equal to 0, we get x equals 1. Now remember, these are what I refer to as our pinpoints. So we're going to put -2 over here, and I'm going to mark that 0 just to keep us in line, and this is going to be 1. Now I'll put our binomials over here, okay. When I have a number greater than 1, I don't know, let's use 3. 3 plus 2, is that a positive or a negative? It's positive. 3 minus 1, is that a positive or a negative? Here's my favorite number in between here, 0. 0 plus 2 is a positive. 0 minus 1 is a negative. Alright, how about over here? Let's say -3. -3 plus 2 is a negative number. Negative 3 minus 1 is a negative number. And now we find the products of our positive and negative numbers. Remember, positive times a positive is a positive. Positive times a negative is a negative. Negative times a negative is a positive. And what did we say? We've got greater than. So we want the positive columns. Again, this is very similar to the other one, isn't it? Just another example. Okay, so it's greater than, not equal to, not greater than or equal to, it's greater than. So we're going to say an open circle, because it doesn't equal 1, it's greater than 1. And we can describe that. X is greater than 1. And we need this one, again, an open circle. And we need to go this way. Okay, so let's see, what should we say? X is less than negative 2. Alright, good for that one? Ready to try another one? Alright, factoring. Sometimes that's the hardest part of working these problems, is the factoring part, right? 2x minus 1 and x minus 2. We set those equal to 0, and we get x equals negative 2. We'll do a little math here. So our pinpoints are 1/2, and I'm sorry, this should be negative. So we got negative 2, negative 1x, and negative 4x gives us a negative 5x. Thanks for catching that. Okay, so that would make this a positive 2. So I'm going to put our 0 in here. I don't want to put it in that close. We'll put our 1/2 in here. And we'll put our 2 in here. And our products, 2x minus 1 and x minus 2. Alright, now we have 3 sides, the greater than, the in between, and the less than. So let's try numbers. Let's try 3, alright? I'm just picking this number at random. You could pick 4, 5, 6, 7, 8, 9, 2.5, whatever you want. You're going to put it into this equation, and you're going to see whether it's positive or negative. So if we put 3 in here, we get 6 minus 1. That's a positive number. If we put 3 in here, that's a positive number. You're starting to see a trend here, right? Let's see. Can we use 1? Sure, why not? So 2 times 1 is 2, minus 1 is a positive number. And 1 minus 2 is a negative number. How about lower than 1/2? What's lower than 1/2 that you'd like to use? Anybody say 0? Of course. So that 0 minus 1 is a negative number. And 0 minus 2 is a negative number. This is positive. This is negative. This is positive. Greater than or equal to? the positive. Don't worry, I've got some more coming up that are hopefully less than. Alright, let's describe our answers then. We want this positive column, and we have greater than or equal to. So in this case, it would be a solid dot, and it would come this direction. And again, a solid dot, and it would go this direction. So x is greater than or equal to 2. And x is less than or equal to 1/2. Alright, let's get a little more complicated. I know you could do it. Okay, now here comes 3 polynomials. It gets a little tougher. Unfortunately, we're still in here with you know what? Let's change it. We can do that. We'll just make up our own problems, okay? Okay, x plus 4. What does x equal? -4. 3x minus 1. X equals 1/3. And x equals 5. So let's see, I've got a -4 way over here. I've got a 1/3 here. And I've got a 5 here. Now I have to do all 3 binomials. X plus 4. This is where this little charting comes in very handy. Okay, 3x minus 1 and x minus 5. Now we're going to do the same thing, only we have 3. Alright, we're going to pick a number that is greater than 5. Should we use 6? Okay, let's use 6. 6 plus 4 is a positive number. 6 times 3, that will be a positive number. 6 minus 5, that will be a positive number. Okay, let's see. How about if we use 1 here? That's going to be easy for us. 1. 1 plus 4 is a positive number. Let's see, 3 minus 1 is a positive number. 1 minus 5 is a negative number. Okay, let's see. My favorite number, I'm going to use 0. So 0 plus 4 is a positive number. If this is 0, it will be a negative number. And if this is 0, it will be another negative number. Alright, we still have this one because we have 3 different polynomials. So let's say -5. -5 plus 4 is going to be a negative number. -5, that's going to be a negative number. And -5 minus 5, that's also going to be a negative number. Now let's see what our products are. Positive times a positive is a positive times a positive is positive. Positive times a positive is a positive times a negative is a negative. Positive times a negative is a negative times a negative is a positive. Negative times a negative is a positive times a negative is a negative. Now, I switched this, right? So when we're looking for less than, we're looking for the minus symbols, right? So in this case, we want this column and this column. And we want less than or equal to, we said. So how are we going to find these? Equal to. So if it's equal to, I've got that one, and I go that way. Okay, so x is less than or equal to -4. Here's the troublemaker. All those numbers are good for this polynomial. So how we write that is 1/3 there. In other words, x is between 1/3 and 5. Okay, so I can have any number in here and it will still be less than 0. I can have any number out here and it still will be less than 0. So you see, trying to figure these out a little more difficult. The chart really makes sure that I've got the correct, and it's much easier to read what the answer is when you see it. All right, ready for another one? How about dividing? All right. I've got some dividing. So let's see. We set this equal to 0, and we get x equal to -2. And here we set this equal to 0, x equals 4. And we have to do the same with the bottom. Whoops, x equals 2. And again, we have a greater than or equal to, so we'll be looking for those positive columns. All right, let's set up our chart. I gave a lot of room here. Pinpoints are 2, 4, and -2. -2, 2, 4, and we'll put all of our products here. X plus, come on, x plus 2, x minus 4, and x minus 2. See, it doesn't matter whether it's on the top or on the bottom. You just put down the binomial. Okay? All right, now is our testing. Okay, if I use 5, random number, 5 plus 2 is positive. 5 minus 4 is positive. 5 minus 2 is positive. Okay, between 2 and 4. Okay, if I use 3, 3 plus 2 is positive. 3 minus 4 is negative. 3 minus 2 is positive. Okay, between 2 and -2. Oh, my favorite number. Yay! 0. 0 plus 2 is positive. 0 minus 4 is negative. 0 minus 2 is negative. All right, now we still have to come out here. See, we're building our columns. We've got more and more binomials to work with. So I'm going to say -3. How about that? -3 plus 2 is positive. That's not right. It's negative, isn't it? And -3 minus 4 is negative, and -3 minus 2 is negative. Okay, we've got to come up with our positive columns and our negative columns. Well, this obviously is a positive column. Positive times negative is negative. Negative times positive is a negative. Positive times negative is a negative, times a negative is a positive. Negative times negative is a positive, times a negative is a negative. And we want greater than, so we want those plus columns, right? This one and this one. And we've got equal to, So let's describe it. This one should be pretty simple, right? And we go this way. So x is greater than or equal to 4. Now this one is our other plus column. Now how did we describe that? Remember we used in between. There we go. You could test that. Take 0 and put it in for the x's and see whether it's greater than or equal to 0. Alright? Now, there's one thing here that we have to remember. I said that we can use 2, right? What is 2 minus 2? 0. No good. Can I divide by 2? Or divide by 0? No. So 2 is not going to work. It has to be an open circle. So I remove this equal sign. It has to be less than 2. It can't divide by 0. Okay? So one little thing that you have to remember when you're using division. Okay, we've got one more and then I think you've got it. Okay. Okay, now, what do we have to do when we have two fractions? How do we add those? Because we're going to move this to the other side and make that greater than or equal to 0. So I know what you're thinking right now. Let's do that. Negative 3 over x plus 2 minus 6 over x minus 3 is greater than or equal to 0. There, now we've got it. Now how are we going to subtract those two fractions? You've got it. Least common denominator. The least common denominator between 2 and 4 is 4. So we would have to multiply this by 2 over 2. So we would get 2 over 4 plus 1 over 4 to give us an answer of 3/4. Least common denominator. Now, our denominator here is x plus 2 and x minus 3. What is our least common denominator? There's nothing in common, so we just have to multiply them. That is our least common denominator. So what are we missing? We've got x plus 2, so we need to multiply this by x minus 3. X minus 3 over x minus 3. X minus 3, we need to multiply that by x plus 2. Okay, negative 3. I'm going to start over here so we don't ruin our... I'm going to go down here. Negative 3x, I distribute inside. Negative 3 times negative 3 is plus 9. Minus, and I'm going to put a big parentheses here. 6 times x is 6x, and 6 times 2 is plus 12. all over the least common denominator. Alright, we have some combining to do. This negative distributes in sides. So we have a negative 6x and a negative 12. So what do we end up with there? Negative 9x, and 9 minus 12 is negative 3. I'm just going to put least common denominator right here so I don't waste some time. And that is greater than or equal to 0. Now, I don't want this negative sign. First of all, we can take out the common monomial, so let's do that. So I get negative 3x minus 1. Now I don't like these negative numbers. I want to get rid of these negative numbers. So I'm going to multiply by negative 1. Okay, if I multiply by negative 1, this 3 ends up 3 is greater than or equal to 0, so it drops off. So now I end up with 3x plus 1 over x plus 2 x minus 3. Now I got one little problem. What did I do? I have to multiply both sides by negative 1. And what happened in the earlier videos when I multiplied or divided by a negative number? It changed the sign, right? So now I have to make this less than or equal to 0. Okay, let's get our pinpoints. X is equal to negative 1/3. X is equal to negative 2. And x is equal to 3. Okay, we'll put negative 2 up here first. And then we had a negative 1/3. And then we had a 3. Okay, let's put the product. We'll start with 3x plus 1. And we'll add the x plus 2. And we'll add the x minus 3. Those are all of our binomials. Okay, anything above 3. Okay, if I pick 4. 4 times 3 is 12. That's going to be positive. Okay, and that's going to be positive. And that's going to be positive. Okay, how about in here? Okay, if I pick my favorite one, 0. So 0 plus 1 is positive. 0 plus 2 is positive. 0 minus 3 is negative. Okay, how about negative 1? That makes that a negative 3 plus 1 is a negative number. Negative 1 plus 2 is a positive number. Negative 1 minus 3 is a negative number. Okay, and okay if I pick negative 3 here. Negative 3, oh, that's definitely going to be a negative number. And that's going to be a negative number. And that's most definitely going to be a negative number. So now we have our products. This is going to be positive. This is going to be negative. Negative times a positive is a negative times a negative is a positive. Negative times a negative is a positive times a negative is a negative. All right. Now be very, very careful. Remember back here we changed the sign because we multiplied by negative 1. We changed the sign. Okay, so when we have a less than, which signs do we want? Positive or negative? Negative. Now let's try and describe these. We got an equal to? Yep, we got an equal to. So x is less than or equal to negative 2. And then we have this section in here. And remember that's the in-between. 1/3 is less than or equal to x is less than or equal to 3. X is in between negative 1/3 and 3. Okay, now you've got a divided by, so let's make sure we don't void anything. Look here, negative 2. If we put in negative 2 in there, it divides by 0. Not good. So we have to take that and change that to x is less than negative 2. Okay, how about 1/3? No problem there. How about 3? 3 minus 3 is 0. No good. We have to change that to an open circle, and we have to take this equal sign off. So it's less than 3. So you see this little chart helps quite a bit when you're working with these numbers. All right, very good, very good. That concludes this video lecture. Hopefully you've enjoyed it. Thank you very much for listening.